Yeah, so the resources that I really used was App Academy Open and this website called Code Wars. All I really did was just did the questions over and over until I actually understood the patterns behind each of the solutions, rather than just like memorizing the solutions and then just going back. Because like if you do the questions like a couple of times over and over, at some point it just becomes memorization, right? So all I did was just did the questions over and over, and each time I would try to remember the pattern and understand the pattern about why this question used that pattern. Oh yeah, I didn't share my screen yet. I'm just answering Aaron's question. Yeah, where was I? Yeah, that's really all I did. And to be honest, like I was also looking at the solutions over and over. And it took me way longer than 2 weeks to prepare for my technical interview. I didn't do Jumpstart, so I was learning on my own. And it took me like, I want to say 2 months to do Intro to Ruby 1 and 2, which is the same curriculum as Jumpstart. So I definitely took a lot longer than 2 weeks to prepare for my technical interview. But yeah, I would say the best way to just study is to just do the questions and try to understand the patterns behind them, because the questions are going to change, but there's only so many patterns that they can ask, right? There's only so many questions that there are so many patterns. The only thing that'll be is like it'll be worded differently, or they might just throw in like one condition that you might have to like account for when you're coding. Yep, no problem. Any other questions, guys, before we get started with today? All right. I think there's no questions. Awesome, right? So, today's Tuesday, right? Yeah. So, welcome to week 2, day 2 of Jumpstart. So, today's gonna be a little different than yesterday. We'll start off with review from some of last week's problems. I have some pre-selected problems. If you guys want me to go over anything specifically, feel free to ask, and I'll be more than happy to go over it. After review, we'll jump right into lecture. We're going to be talking about nested loops today. After lecture, I will split you guys up into pairs, so you guys can get started pair programming. There is 3 of you guys, so I'll just put all 3 of you guys in a single room, and we'll talk about how that'll work at the end of lecture. But yeah, let me share my screen so that we can get started. Share. All right, can everybody see where it says 2 initials, random activity, 2 initials?
Yes.
Did I get cut out of the class? Can you guys hear me?
You're kind of coming in and out with your microphone.
Hello? Is my stuff? Hello.
We can hear you.
Okay. I'm sharing my screen, but it's just like I don't know if you guys are talking, but I can't hear this. Okay, yeah, I can't hear you guys. So I guess we'll just use the chat for today. Sorry, guys. I don't know. What is good with okay, yeah, so let me just share my screen. But were you guys able to see? Can you guys like see my screen?
Yes, I can see your screen.
All right, awesome. Actually, I can hear you guys now too. Okay, that's weird. Perfect. All right, awesome. So yeah, I'll start us off with the three-step approach that we should always use whenever we encounter a coding problem. These three steps really just help break down the process of coming up with a solution, a working solution, I should say. And it really helps to make sure that you do not get lost. Sometimes you'll find yourself as you're coding, you'll get lost. You're like, oh, what was I supposed to do at this step, or something else. So this really helps to make sure that that really doesn't happen as much, because your chances are you're still going to get stuck because some questions are just tough. But yeah, so step one is to read the prompt and put it in your own words. This really helps to make sure that you understand what the prompt is actually asking of you. Some questions are worded weirdly, some questions are worded vaguely, intentionally, and for some questions, you might not even know the concept, right? So for questions, for situations like that, what you can do is take a look at your test cases. So your test cases are basically your given inputs and your expected outputs, right? So this is saying, hey, if I give you a method Kelvin bridges, this is what I expect. So this is just called one test case. So you can just look at your test cases and see if that aids in your understanding of the problem. If you're in like an interview setting, this is where you'll have a conversation with your interviewer, and they'll make sure that you fully understand what the question is asking before you get started. Of course, it is still up to you to ask the questions. They're not just going to spoon feed you everything. It's still up to you to ask the questions that you need to clarify the question. Step two is to come up with a high-level overview of your approach to the problem. This high-level overview doesn't need to be in code. It could be in pure English, or it could be a combination of code and English. Completely up to you, whatever you're most comfortable with. And it may help to write your high-level overview down in the editor, if that's what you like, because it may help when you start coding to just have like a piece to reference to. If you get stuck on any step, you're like, oh, what did I need to do over here? And you can just look back at your high-level overview and get what you were trying to do. And then step three is to just take your high-level overview and turn it into actual code. So seeing those three steps in action, this question is asking us to write a method to initials that takes in a person's name string and returns a string representing their initials. Okay, not really too much to misinterpret over here, right? If you look at our test cases, we're going to be given a string that is a person's name, and we're expected to just return another string that just contains only the initials of all parts of their name, right? So over here we have a first name, last name, but then for Mary, we have Mary language. So for that, for Mary language, we include MLG. So for this question, what we'll do is the first thing we need to do is actually split this on a space. We want to split it on the space because a space is used as a delimiter to let us know that one word is ending and another one is about to start. Right? So if we split this right on the space, what Ruby does is it gives us an array containing two elements, right? It'll contain Kelvin and another element, bridges. For Mary Lagrange, since there's two spaces in here, we're going to get an array of three elements. Since we split it into two spots, we'll get three elements in our array. First element will be Mary, the second element will be love, and then the last element will be Grange. Once we have this array, we want to iterate over this array. As we iterate through each element, as we hit each element in our iterations, we'll grab the first character of each element. So we'll have this array of Kelvin bridges. As we start our iteration, the first elements will be Kelvin. We'll grab K and we'll add it to a string. Then we'll move on to bridges. We'll grab B and we'll add it to a string. And then we have our string of KB. And then we can just return that at the end. Can you guys hear me better now? All right, awesome, perfect. Yeah, I just, yesterday I had my headphone in on my right side, and I had my fan on the left side, so you guys weren't really hearing the fan. But now my right headphone wasn't working, so I put my left one in, and the fan is still on my left side. So I guess the fan was just messing with it. Sorry, guys. But yeah, Minhwa, did you hear my high level approach about what I said? Everything? I can just repeat it if you guys did not hear it. Did anybody hear it? Oh, so you guys started good. All right, awesome, perfect. All right, so yeah, let's move on to step 3. So the first thing we'll do is we will split this name on the space. So we'll call this parts, because this is going to be holding an array which is going to hold parts of names or parts of a name. So the parts is equal to name dot split, and we'll split this on an empty space. Next up, we'll define our string that will return at the end. We'll just call it initials, because this string is going to hold the initials of the name or of the person's name. Next up, we want to iterate over our parts array. So we'll do parts dot each, and then this could be a one-liner, so we'll keep it a one-liner, and we'll do pipes. And for our block parameter, we'll call it part, because each element inside of this parts array is a single part of a name. So we'll just call it part. And now all we want to do is grab the first character of our part that we're currently at. So we'll do part at the index 0. And we want to add this into the initials string. So we'll do initials, and we'll add that to our, we'll add the part at the index of 0 to that. And then at the end, we'll just do return initials. We give that a run. And next we get KB, MY, MLG. Awesome. Any questions about this?
You don't have to put an end for the parts.each.
No, we would put an end if we use the do keyword over here.
Okay.
But since we're using open curly brace, we just need to end it with a close curly brace.
Gotcha.
Any other questions? All right, it looks like there are no questions, so I wish I could tell you guys, but even I don't know what's on the technical interview. All right, so next up, let's move on to format name. All right, so this question is asking us to write a method format name that takes in a name string and returns the name properly capitalized. Nice. All right, so if you take a look at our editor, they give us a little hint. They say use str.uppercase and str.downcase. So the way the .uppercase method works is if you give it a string and you call the .uppercase method on it, it returns the new string where every character has been uppercased. And the downcase probably works the same, right? If you give it a string, the .downcase is just going to return the new string where every character has been lowercased. So for this, we'll do a similar thing from the last question where we split on the space, because we want to be able to differentiate between the first name, last name, or if there's multiple parts in the name. So we want to be able to differentiate between different parts. And what we'll do is, so if you see that we're passing the string of Chase and Wilson, right? So Chase is all lowercase, Wilson is all uppercase. We're expected to return the C uppercase, everything else in Chase is lowercase, and then in Wilson, only the W is left uppercase, everything else is lowercase. So what we'll do for this one is we'll do that split, just like the last question. At each element, so let's say we're at Chase, we'll grab the first character, we'll uppercase it. We'll grab the rest of the string and we'll lowercase it. We'll mash those two together and we'll shovel them into an array. And we want to add them to an array instead of a string this time. As you can see over here, since we're expected to return a string, we'll add them to an array because at the end, we'll use the .join method and we'll join them on a space. So what that's going to do is grab all of the elements from our array and join them, and in between each element, it'll add a space. And that's perfect because if you try to do a chase plus a space, and we keep on adding that to a string that will return at the end, since we do a part plus string, a space, it's going to do that for this part and for this part. So this will be Wilson plus a space, right? But they don't want that space at the end, right? It'll also do the same for Brian, Crawford, Scott. It'll be Brian space, Crawford space, Scott space. But you can see that these codes let us know that there should be no trailing space. So that's why we'll use a dot join, because it's going to put them between each element, not at the end of each element. So yeah, let's start this off by using that, by doing that split. So we'll just call this parts again. So the parts is equal to str.split, and we'll split this on an empty space. And we'll create this array. We'll just call it new parts, I guess. And new parts is equal to an empty array. And we'll iterate over the parts array. So we'll do parts dot each. I'm pretty sure this could be a one-liner, but let's just do a multi-liner this time around. Each element from our parts array is just a part of a name, so we'll just call it part. And now, like I said, what we wanted to do was grab the first index, the first character of the part. So we'll do part at the index 0. We'll call the dot upcase method on it. And we'll add part at the index of 1 dot negative 1. So this is creating a range. This is telling Ruby, hey, grab everything from the first index up to the last index. Remember that negative indexing goes to the end of the array, right? So, sorry, end of the string. -1 is going to be the very last character. -2 will be the second to last. -3 will be the third to last. So negative indexing starts from the end. So this is telling Ruby, grab everything from the first character. So for chase, it will be the H all the way up to E, and then we'll downcase that. So we'll do that downcase. Once we have that mashed together, we'll just shovel it into our new parts array. So we'll do new underscore parts, and we'll shovel that in. And then at the end, we'll just do return new underscore parts dot join, and we'll join this on an empty space. So now if I give it a run, you'll see we get Chase Wilson, Brian Crawford, Scott. And if I change these put statements to P statements, you'll see that there is no trailing space at the end, right? As if I had done this as a string, right? And I had done plus equals, and then I had tried to add in a space. If I give that a run, whoa, oh, yeah, I can't really join the string, right? Give that a run. You'll see that trailing space at the end, but that's not what they want, right? They do not want that space. So yeah, any questions about this? All right, getting a whole bunch of no's. Safe to assume there are, I got a no from all of you guys also, sweet. Right, safe to assume there are no questions, so we will hit reset. And we'll move on to our next and last one, which is valid email. All right, so this question is asking us to write a method is valid email that takes in a string and returns a Boolean indicating whether or not it is a valid email address. All right, and if you look inside of our editor, they do give us some rules over here. Say, for the sake for simplicity, we'll consider an email valid when it satisfies all of the following. So the first rule is that it contains exactly one @ symbol. The second rule is contains only lowercase alphabetic letters before the @ symbol. And the last rule is contains exactly one dot after the @ symbol. So if you take a look at our test cases, you'll see that this ABC at xy.z is true because it contains exactly one @ symbol. Before the @ symbol, there are only lowercase alphabetic letters. And then after the @ symbol, there's only one dot. Same thing for jdoe@gmail.com. Only one at symbol, only lowercase alphabetic letters before the at symbol, and after the at symbol, only one dot. The next one, we have jdoe@mail.com. This clearly has more than one at symbol, so not exactly one at symbol. So it doesn't satisfy that first rule, so we just return false. Next up, we have jdoe42@gmail.com. We have one at symbol, but there's not only lowercase alphabetic letters before the at symbol, right? There's also numbers over here. So it doesn't satisfy that second condition, we return false. Next up, we have jdoe@gmail.com. This returns false because there's not exactly one at symbol, right? There's no at symbols. So that returns false. And then lastly, we have az@email. So this only has one at symbol, only lowercase alphabetic letters before the at symbol, but after the at symbol, there's not exactly one dot, right? There's no dots. So we just return false for that too. So for this one, we'll handle this case by case. I'll kind of combine steps 2 and 3 over here because it's just going to be a whole bunch of talking and it's going to get confusing. So we'll handle the first case first. So the first case is telling us it contains exactly one at symbol. So all we'll do over here is we'll use the dot split method to make sure that this string only has one at symbol. And we'll call this variable parts. Yeah, let's call it parts. Can't think of a better name right now. We'll just call it parts. Parts is equal to str.split, not list, split. And we want to split this on the at symbol. So now, like let's say we have abc at xy.z. If there's only one at symbol, it's only going to do one split. And if it does only one split, we should get an array with 2 elements, right? We would get abc, and then the second element would be xy.z. Over here, it would also do exactly one split, and we would get an array of 2 elements, jdoe, and the second element would be gmail.com. Down here, it would do 2 splits, right? So we would get an array of 3 elements. There would be jdoe, the g, and mail.com. That's 3 elements because we did more than one split. Down here, this would still be one split. So we would still get an array of 2 elements, jdoe42 and then gmail.com. Down here, we wouldn't do any splits. So we would just get an array with the 1 element in it, jdoe@gmail.com. It's not going to do any split. So it's just going to give us this element as an array. So all we have to do to satisfy this first check is say if the parts dot length is not equal to 2. If it's anything other than 2, that means that we either did too many splits or too little splits. So all we'll do is if it's not equal to 2, we'll return false. And notice how I'm not doing if parts dot length is equal to 2, return true, right? Because this return statement, whenever we hit a return statement, Ruby will force exit the method. It's not going to do anything else in that method if you tell it to return, right? Return is usually something, or return is something that you put at the very end of a method. Over here, the end of our method would be if this is, if we did too many splits, right? Because we already know right away that our string is a false, our string is invalid. So we just return false right away. There's no point in me continuing on and doing these next 2 checks if I know right away that my string is invalid, right? So that is the end of my method. But if it is valid, I should continue. So that's why I need to check the inverse over here rather than making sure that parts dot length is equal to 2. And then doing like a return true. So next up, what we'll be doing is checking to make sure that there's only lowercase alphabetic letters before the at symbol. Sorry, guys, I'm gonna just get some water real quick. So yeah, so for this one, does that also filter out 2 or more at symbols? It filters out every single at symbol inside the string. The entire string could be at symbol and it'll filter everything else. You can split the entire string on everything. The number of elements. So yeah, so what we're doing over here, so it's saying exactly one at symbol, right? So if I split this string on its at symbol, I'll get an array of A, B, C, and X, Y, dot Z, right? If I take this string, let me just copy the codes too. And I split this on its at symbols, it's going to give me an array of 3 elements, J, Do, G, and mail.com. If I split this on the at symbol, well, there is no at symbol in there, right? So we'll just get an array with just jdo@gmail.com. So out of this, right, we have 1 at symbol, 2 at symbols, no at symbols. So we can see that every single time there's another at symbol, the number of elements in our array increases, right? Or if there's no elements, then it just, no at symbols, it just remains at 1, right? So if it's looking at this little thing, we can see that the only way there can only be 1 at symbol is if we only do 1 split and end up with an array of 2 elements, right? If I do more than 1 split, I'll end up with an array that's greater than length 2. If I had another at symbol in here, like let's say, instead of this dot, I had an at symbol right here. This would return me this array, right? Because now it's going to split and do JDO, G, mail, and the com. So it's going to split everywhere there's an at. So if there's more than 1 at symbol, it's going to return an array of a lot more elements than just 2 elements. If there's only 1 at symbol, exactly 1 at symbol, I should have an array of exactly length 2. And that's how I know it's valid so far. Does that clear it up, Gerard? What's so confusing? Oh, so this part is checking right here, right? We're doing if parts.length is not equal to 2, right? So I'm saying, okay, if it's not equal to 2, which means it could be less than 2, or it could be greater than 2. If it's anything other than 2, return false. It's false. Awesome. All right, perfect. All right, so yeah, next up with this second check, what we'll do is, since we know that if we make it to line 14, our array must be of length 2, right? So what I'll do is I'll just store these in variables, so it can be a little easier for us to understand and read this code. So I'll do first, which is the first element, the whatever came before the at symbol. I'll do part at the index of 0, or sorry, parts at the index of 0, and then second, which is what came after the at symbol, I'll call this parts at index 1. So it's saying it contains only lowercase alphabetic letters before the at symbol. So our first variable, the string that is stored in the first variable, should only contain lowercase alphabetic letters. So I'll just call this variable alphabet is equal to a string of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. I hope that's everything and I didn't miss anything. So now this is all lowercase alphabetic letters, right? So every character that is in here must also exist in here. If it doesn't, that means it's either a lowercase, an uppercase alphabetic letter, or it's a number, or it could be a special character, right? So what I need to do now is iterate over the entire first string. So we'll do first dot each underscore char, do pipes and keyword. We'll call our block parameter char. And now I want to make sure that every single character that I hit, that I iterate over, is inside of this. If it's not, I know my string is invalid, right? Because I just ran into a character that is not a lowercase alphabetic letter. So I'll say if alphabet dot include question mark char, and we want to put a bang sign over here to let Ruby know that not. So if the character is not included in the alphabet, then I want to just return false. Notice how over here I still didn't do a return true, right? Because I'm making sure that I need to iterate over every single character, right? If I put a return true over here, if I do alphabet.include char return true, it's only going to hit the first character. So let's say like A, or like better yet, J.42, right? So it'll go to J, and it'll be like, oh, is J inside the lowercase alphabetic thing? It is. Let me return true. It's not going to go on and do D or O or E or 4 or 2, right? As soon as it hits J, it's just going to return true. So that's why we want to check the inverse over here. We want to make sure that we iterate over the entire string and only return when we run into an invalid character. So if we make it past this return false, so it's safe to assume that so far we have an exactly one @ symbol and only lowercase alphabetic letters before the @ symbol. So last check is contains exactly one dot after the @ symbol. So for this, we'll do the same exact check as this. All we'll do is do return second dot split, and we'll split this on the dot. So the second, remember, is coming from over here. This part's at the index 1. So it's grabbing the second element from that parts array, which was whatever came after the @ symbol. And we'll check that this length is equal to 2. If it's equal to 2, then I only did one split, as one split on one period, and it's good. If the length is anything other than 2, I either did 2 little splits or too many splits. So it's not valid. This will return false. So if we give that a run, whoa. I still have this habit of not spelling include correctly. Nice. So we get true, true, false, 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 false. Awesome. Any questions about this one? All right, we got 2 no's, 3 no's. All right, awesome, perfect. All right, so let's hit reset. I will stop my screen share. Do you guys want a quick break or anything? If you guys do, just let me know.
Quick question.
Oh, okay. Was it about that question?
No, actually, I was wondering if you can go over the rotate array practice question, because that's the one that I'm kind of having a hard time understanding on my own. Is there any time to go over that, or do you want me to direct message you back?
Yeah, it would be better if you direct message, because it's already 7:13. I do want to finish lecture by 8 o'clock. So we guys have like an hour for pair programming. Yeah. But yeah, right after pair programming, just shoot me a message on Slack and I will walk you through it.
Okay, thank you.
Awesome, no problem. All right. But yeah, does anybody want a break? If not, we will jump right into lecture. All right, awesome. Looks like nobody wants a break. Let me share my screen so that we can get started. The lecture. All right. Share screen. Week 2, day 2. Share. All right. Can you guys see where it says week 2, day two nested loops, and then a whole bunch of blankness?
Yes.
Sweet, awesome, perfect. All right. So yeah, the topic for today's lecture is going to be nested loops. And also, I think my headphone is good now. I'm going to try to turn the fan towards me and see if you guys can still hear me fine. Can you guys hear me fine?
Can you talk again?
Oh, should I continue talking? So I'll just answer Gerard's question. So yeah, this is basically just a loop inside of a loop, and we'll talk about exactly how this behaves in Ruby and basically any other programming language. The behavior will be the same of a loop, a nested loop, and we'll talk about some use cases about a nested loop and why this would be useful. Did everybody hear that part good? Did I sound muffled?
There's a little bit, but I
Okay.
can hear you okay.
Okay. Okay. All right. Awesome. So, yep. We'll just put this down. Having a loop inside of another loop, making a nested loop. So, to explain a nested loop, you can basically think of the outer loop or the first loop as like the floor of a building. And the second loop or the inner loop can be seen as the steps that you take to get to the next floor in the building. So let's say we wanted to create an inner loop like this. So we'll create a range from 1 to 3 and we'll iterate over that. So we'll do parentheses 1 dot 3 dot each do pipes floor. And then we'll print out the floor that we're currently on. So we'll do p floor. And then we'll also create another range inside of this range. So we'll do parentheses 1 dot 5 dot each do, and then we'll call this parameter step. And then we'll print out each step. So we'll print it out with some dashes. So we'll do p dash 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 plus step dot 2 underscore s, and we'll put our end keyword for the inner loop and our end keyword for the outer loop. And we'll just pop open a terminal. We'll just to the right. Let me toggle word wrap so words do not get cut off. There we go. Nice. And let's give this a run. Nice. So you'll see we got this 1 and then dash dash all these prints 2, all these dash prints 3, and all these dash prints, right? So let's talk about what exactly is going on over here. So on line 7, when Ruby reads this file from line 1 all the way down to line 7, this just comments, so Ruby just ignores that. It gets to line 7 and it's like, all right, I need to create this range from 1 to 3. And we're calling the dot each on it. So Ruby's like, I'm going to iterate over each element. And each element is going to be referred to as a floor. So Ruby's like, cool. The first iteration is at 1. So we print out the floor. So we print out that 1. And then it's like, Ruby's like, all right, I need to create a range of 1 to 5. If Ruby isn't like, hey, I'm inside of another loop, I shouldn't be inside of another loop right now, right? Ruby doesn't care about all that. Ruby just does what you tell it. So Ruby creates that range from 1 to 5, and it's like, all right, I need to iterate over each element, and each element is going to be referred to as a step. So this creates this range, and it starts off at 1. So Ruby's like, all right, I need to print these dashes with the step. So it prints out dash dash 1, and then it gets to the end keyword, and it doesn't immediately go on to this end keyword because it's still not done iterating over this range, right? We're only at 1, and there's still 2, 3, 4, and 5 left for us to iterate over. So Ruby continues on with the iteration. It moves on to 2, and then it prints out the dash dash 2. Then it moves on to 3, and then it prints out dash dash 3. Then it moves on to 4, and then it prints out the dash dash 4. Then it moves on to 5, and then it prints out the dash dash 5. And now we are done iterating over this range. So Ruby's like, all right, I can now make it past line 11 because line 11 was telling Ruby that this is the end of this dot each. So now we can move past line 11. And past line 11 is just another end. And that end belongs to this dot each, the outer one. So Ruby's like, all right, I'm not done iterating over this range. Let me move on to the next element. And the next element for this is 2. So Ruby does print out that 4. So it does P4 and it prints out that 2. Next up, it recreates this range. Ruby isn't like, hey, I just created this range in this last iteration. Why am I having to create this again? Like I said, Ruby just does what you tell it. So it will recreate that range. And remember that for each iteration of any loop, it's going to run the code from top to bottom, right? So it's going to recreate that range and then iterate over that. It's going to start off at 1. It's going to print out dash 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 1. Then it's going to move on to 2, print out dash dash 2, move on to 3, print out that dash dash 3, move on to 4, print out dash dash 4, move on to 5, print out dash dash 5, and then that's the end for the inner loop. Ruby's like, all right, at the end over here too, let me go back up, see if I gotta do anything else. And it's still not done iterating over the entire range. So it moves on to the next element, which is 3. And then it prints out that floor. So it prints out 3. And then it recreates that range from 1 to 5. And then it's like, all right, I need to iterate over each element. Each element will be referred to as a step. So it starts that off again. It starts off at 1, prints out that dash dash 1, moves on to 2, prints out that dash dash 2, moves on to 3, prints out that dash dash 3, moves on to 4, prints out that dash dash 4, moves on to 5, and prints out that dash 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 5. And that is the end for the inner loop. And then Ruby reaches this end and it's like, all right, do I have anything else left to do? And it doesn't, right? We just iterate over the entire outer range too. So that's the end for the outer loop. And then there's nothing else after line 12, right? So that is the end of our code. Nice. Any questions about that? So the key over here was Ruby will not move on to the next iteration of an outer loop until it does everything inside of an inner, inside of its code, even if it's a loop, right? Ruby will take a break from the outer loop and do everything that the inner loop is telling it. And of course, if there was another loop nested inside of here, this loop would wait for the inner loop to get finished running. And this loop would wait for both of those inner loops to finish running and all that stuff. So the point here is if it's nested, Ruby's gonna wait for it to finish running before it moves on to the next iteration. Would a while loop followed by an if loop be a nested loop? Yep, anything that's a loop can be nested inside of another thing and still be called a nested loop. So if you had 10 nested loops, so let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So Ruby is gonna let's assume this is all code, right? Let's assume this is all this dot each, creating some range and iterating. Let's just assume that is in place of these numbers, right? So Ruby's gonna run into this line first. It's going to initialize that range. It's going to iterate over that. Then it's going to run into this line, initialize that range, iterate into that. Run into this line, initialize that range, iterate into that. Run into this line, initialize that range, run into that. Do the same thing for 5, do the same thing for 6, do the same thing for 7, same thing for 9, same thing for 8, same thing for 9, same thing for 10. And since there's nothing else nested inside 10, it's going to run all of the code inside of 10. Then it's going to move on to the next iteration for 9. Once everything inside of 9 is done running, it's going to move on to the next iteration for the 8. Once everything inside the 8 is done running, it's going to move on to the next iteration with 7. Yep. And then it just works its way back up until the next iteration of the 1, in which then it goes right back down and then goes back up. Nice. I'll just take that off because that was numbers and not code, so I don't want anybody to be confused and notes later on. But yeah, any other questions about how a nested loop behaves? All right, looks like there are no questions incoming. Safe to assume there are no questions. So I got to know from everybody. Next. All right, so let's talk about a use case about this, a nested loop. So one use case can be finding the pairs in an input array using a nested loop. So let's say we have an array, we'll call it ARR, and it's equal to an array of A, B, C, and D. And we want to get all possible pairs from this array. So we'll define a method, we'll call it all underscore possible underscore pairs, and we'll pass in a parameter ARR. And we'll iterate over this ARR. We'll do our dot each do types char1. And then for the inner loop, we'll iterate over the same array. So we'll do array dot each do types char2. So one thing to note over here is, although I'm iterating over the same array, I do need to be able to differentiate between block parameter for the outer loop and block parameter for the inner loop. Because if I don't, Ruby is going to get confused and be like, well, which one are you referring to? So we need to be able to differentiate between different block parameters. So inside of here, all we'll do is we'll print out the char1 and char2. So we'll do p char1 plus a colon plus char2. And we'll put our end for the inner loop, and for the outer loop, and for the method block. And we'll invoke our method, and we'll pass in that ARR. So we'll do all underscore possible underscore pairs. We'll pass in ARR, and we will clear this up and give that a run. Nice. So you'll see we get all of this. And if you take a look at all of this stuff, this is basically just all possible pairs from this array, right? So we get AA, then we get AB, then we get AC, then we get AD. Then we get BA, BB, BC, and BD. Then we get CA, CB, CC, and CD. And lastly, we get DA, DB, DC, and DD. So one thing to note over here is that the elements on the left-hand side of the colon do not continue on until the elements on the right-hand side of the colon are done iterating through the entire array, right? And that's because our inner loop is char2, right? Our outer loop, what was before the colon, is char1, which is coming from the outer loop, right? But the outer loop is not going to move on to its next iteration until the inner loop is done iterating fully. So yeah, any questions about how this works?
Wait, can you explain the last part again? So you said that it doesn't iterate, but then you have the P underneath both of them. So how does that work?
So yeah, you'll see that this is nested inside of this inner loop, right? So we have this outer loop, there's a nested loop in here, and then this P char1 is part of this inner loop, right? It's not really a part of this outer loop, right? Because it's still like kind of a part of it because it's still inside of its dot each do, but it really just runs once we start iterating over the inner loop, right? So once we start iterating over the inner loop, Ruby prints out char1, which it gets from the outer loop. So you'll see that that's why it says A, and A. And then it prints out that colon and then char2. The inner loop, remember, it just iterates over, right? There's nothing else nested inside of the inner loop. There's no nested loops in here. So the inner loop just keeps on going on to its next iteration. It goes on to A, B, C, and D. Once it reaches D, the inner loop is done, right? Because we've just iterated over the entire array. So Ruby finishes off the inner loop, and then it moves on to the next iteration of the outer loop, which is B. So char1 becomes B. And then you'll see that next up, we move on to these 4 Bs. And then the inner loop starts iterating over the same exact array, but we reference each element of the inner loop by using char2. So we'll print out BA, BB, BC, and then BD. So it's iterating over every element of the array. Once it's done running, once it's done iterating over the entire array, that's when the outer loop moves on to its next element, which is now C. And then we print out CA, CB, CC, CD. And then once the inner loop is done running, that's when we move on to the next iteration of our outer loop again, which is D, and then DA, DB, DC, and then DD.
Okay, that makes sense. Thank you.
Okay, awesome, perfect. Any other questions, guys? Alrighty. Looks like there's no questions. So let's move on to our next thing, which is all unique pairs inside of an array. So if you take a look over here, right, we're getting a lot of duplicates, right? AA are the same two elements, so that's a duplicate. Then we see AB, AC, and then AD, and then we see BA, right? That's basically just AB, just in a different order, right? It's the same two elements, just in a different order. So that's a duplicate right there. Then we see BB, that's another duplicate. It's the same two elements. Then we see BC and then BD. Then we see CA, which is basically just AC, just in a different order. So that's a duplicate. Then we see CB, which is basically just BC, but in a different order. So that's a duplicate. Then we see CC, which is just the same element. So that's a duplicate. And then we see CD. And then we see DA. We already saw AD. So it's just the same two elements, just in a different order, duplicate. DB, we've already seen BD. So that's a duplicate. DC over here is just CD. We've already seen that. It's a duplicate. And then DD is the same two elements. It's a duplicate. So we need to be now get the unique pairs, right? So let's have a comment here. This says finding the unique pairs in an input array using a nested loop. And we'll use that same array. So we'll do ARR is equal to ABCD. And now we'll define our method. We'll call it all underscore unique underscore pairs. And it'll take in that ARR parameter. And now to get this uniqueness, we use the index. And I'll show you guys how this works. So we'll do ARR dot each underscore width underscore index do, and then pipes char1 comma IDX1. And then for our inner loop, we'll iterate over that same array. So we'll do ARR dot each with index do pipes char2 comma IDX2. And now here's how we make sure they're unique. We use an if statement. So what we'll do is we'll do if IDX2 is greater than IDX1, then we will do that print. If they're not, so we won't do it. So we'll do P char1 plus colon plus char2. So put our end for the if keyword, and for the inner loop, and for the outer loop, and for the method block. Sorry, the method. And then we'll invoke our method. So we'll call it all unique pairs, and we'll pass in that ARR variable. And now let's get some spaces in here. If we give that a run, you'll see that we get a lot less output, right? And we get AB, AC, AD, BC, BD, CD. So we get no duplicates over here, right? We completely omitted that AA. We printed out AB, AC, AD. Then we did not print BA. We did not print BB. We only printed BC and BD. We did not print CA, CB, or CC. Those are all duplicates. We only printed out CD. And then lastly, we didn't print anything that started with D because we've already seen everything, right? We've already seen AD, BB, CD, and then DD is just a duplicate. So we got all unique pairs. And it basically just works by saying the index one, the outer loop is basically like a placeholder. Like it's saying any index that is less than me, we have already seen. So don't worry about printing that again. Any questions about that? What's weird about it? Yep. So the index of A is less than the index of B, right? I'm not comparing the characters, I'm comparing their indices. Yep. Any other questions? Okay, I don't see any. Okay, got no's. All right, safe to assume there are no other questions. So let's comment that out, and we'll move on to our next topic for today, which is two-dimensional arrays, also just called 2D arrays. So this is just an array inside of another array, hence an array with subarrays inside of them. So an example, or a couple examples over here, can be this. So over here, you'll see that we have these two sets of square brackets, right? So I just put a space in between them so it's easier to see. But you see that here we have an array of 1, 2, and that's inside of another array. So this is a 2D array with a subarray of 1 and 2 in it. Over here we have a 2D array with multiple arrays in it. So over here, these are all subarrays of this bigger array, this 2D array. The first element inside of this 2D array is the subarray of 1, 2. The second element inside of this array is 3, 4. The array of 3, 4, and the third element inside of this subarray is the array of 5, 6. We can also write these arrays on multiple lines. So Ruby doesn't complain about writing arrays on multiple lines or on one line. So you can definitely do something like this. So we'll do array is equal to an open square bracket, and then we'll put in a subarray of 1, 2. And then we'll put in another subarray of 3, 4, and 5, and then another subarray of just 6. We'll close this off. And one thing to note over here is that these subarrays can be of different lengths, right? They don't have to be the same exact length. Like if you define, or if you create this first subarray of length 2, you don't have to make everything else of length 2. It can be any length. So now if we print out this array, so if we do PARR, you'll see that Ruby will not throw an error. It'll just print out that array all on one line. So if we clear this up and we give this run, you'll see that we get that array all on one line. If I want to get the length of this 2D array, I still just call the .length method on it because this is still just an array. So all array methods will still work on this. So if we do PARR.length, this will return 3. And that's because there are 3 elements inside of this array, right? There's different number of elements inside of each subarray, but the outer array isn't really concerned with that. It only cares about the elements that are in it, directly in it, I should say. So that is this element of this subarray of 1, 2. The second element is the subarray of 3, 4, 5. And then the third element is just a subarray of 6. So there's 3 elements, right? And another way to just note that is because remember that elements in an array must be comma separated, right? And over here, we only put 2 commas, right? This comma and this comma. So that must mean we're separating 3 elements, right? So if you'll see if I give that a run, you'll see that we get 3. Nice. If you want to index inside of a subarray, so if I want to grab, like, let's say this 3 right here, I need to do what is called a double index. So what that looks like, so we'll have commentary index inside of a subarray. So usually when we just do an index, so let's say we do PARR at the index 1, this is going to return as a subarray of 3, 4, and 5. So a single index is going to return us, let me comment this out so we don't see that. We'll see that array of just 3, 4, 5. And now if I want to grab that 3, I need to index into this array's index 0. So that'll just be PARR at the index 1 at the index 0. And that's going to return 3. Nice. You see that 3. Any questions about any of that?
Just a side question. How did you hash multiple lines?
Oh, like commenting on multiple lines?
Or like, how do you turn multiple lines into like comments?
So all you do, are you on a Mac or Windows?
Mac?
Okay, so you just select them.
Uh-huh.
So if I want to turn all these, like let's say all of these lines into a comment, I just highlight all of them and then push the command and the /. The / is the one with the question mark on top of it.
Okay.
And if you want to comment it back in, you just push that again. So if one will comment it out, another one will comment them back in.
Okay, thank you.
Yep, no problem. So you said which ARR at the index 1 at the index 0 is 3. How is that? Yeah, so it's like that. So as you can see, ARR at index 1 returns this array, right? So we can basically think of this as evaluating to this. And now if I just have this array, how would I get 3, right? Yeah, so this has an index of 0. So inside of here, I would just index it to 3. So this basically just all of that on one line. Awesome. All right, let's comment this out and let's move on to iterating over a 2D array, which is going to talk about another use case for nested loops. So let's say we now have, let's put a comment here that says how to index over a 2D array, or how to iterate over a 2D array. And we'll do ARR is equal to subarrays. So first subarray is going to be A, B, and C. The second subarray is going to be D and E. And the last subarray is going to be F, G, and H. And we'll close this 2D array off. And now to iterate over this array, we still just use the dot each because this is still just an array. So we'll do array dot each do pipes, and we'll call this subarray, right? Because as I iterate through this array, each element that I'm going to hit is another array. So it's a subarray inside of this array. So we'll just call it subarray. And I'll print out each subarray. So we'll do p subarray. And next we'll iterate over each subarray. So we'll do sub underscore array dot each do pipes le. And we'll just print out each element. So we'll do puts le. And then we'll put our end keywords for the inner loop and for the outer loop. And that should be it. So if we give that a run, you'll see that we get this subarray of A, B, C being printed out because we do a pre-subarray. And then we iterate over that subarray and we print out each single element. So we'll print out that A, B, and C. Next, we'll move on to the next subarray, which is DE. We'll print that out. Then we iterate over that subarray and we access each element and we print it out. So we print out D and E. Next up, we move on to the last subarray, which is FGH. We print that out. Then we iterate over that. We access each element by iterating over it. And we print out each element and we got F, G, and H. Nice. Any questions about that? Or like anything from today's lecture? That was really the last thing I had for lecture. So if you guys have any questions, feel free to ask. Okay, if you think of any questions at any point in time, just shoot me a message on Slack and I will help you out. But I don't see any questions coming in. Yep, no problem, guys. All right, so I will comment this out. And I will send you guys these notes on Slack so you guys will have access to them as you guys are pair programming. So let me put an end.